Hi guys, nice to see you again. This is Entis. So I'm going to continue what I have started earlier on my video about chatbot template using LangGraph. So in this second video, I'm going to add on the capability of processing documents, and then therefore the chatbot will be able to respond based on the provided data from that documents. So I see you on the coding session shortly. Hello guys, so I have the code here with me. So let's start with the process of setting up the data for the chatbot. So I'm going to set up a few things here. One is processing the data, and second is to store that data into a vector database. So the first thing that we need to do is import a few libraries. One of them is the document loaders. I'm going to use the Hugging Face datasets, and then LangChain text splitter. So we are going to put that data into smaller chunks. And then once we have the data, once we have the chunk, then we need to put them into vector database. In this example, I'm choosing Qdrant vector database. Of course, you can use any other vector database as you want. So let me run the libraries, and then next one is initiate or setting up the configuration for the Qdrant. So I'm going to use localhost with the standard port of 6333, and then the name of the vector database for this case is going to be transformer underscore docs. Why the name is transformer underscore docs? Because the data that I'm going to download from Hugging Face datasets is going to be about the transformer documentations. And then the next line here that I have highlighted, this is going to set up the Qdrant client vector database. So before processing with the Qdrant client database, we need to process the datasets and put them into smaller chunks. So I have indicated here the chunk size will be 700 words, and then there will be overlap between chunks about 50 words. And there you go here, the transformer doc. We are going to download the data from Hugging Face, and then we are going to split them into small chunks. By the way, I'm just processing 5 documents only, so just to keep it small for this exercise. Let's print and check out what we have here. Yeah, just check it quickly. So we have the metadata and we have the page content, which is the text from the documents here. Next, we are going to convert the text or the chunks into vector embedded. So here I have declared functions here. I'm using the vector embeddings from OpenAI, but feel free to use any other vector embedding as you wish. And then the next one is we also need to create the collections name if it doesn't already exist. But I believe I have created one already, so it should be existed already. So as you can see here, the collections name is referring to the vector database name, and then this is going to store the vector, which is the size 1536, the standard size for OpenAI vector embedding. The next ones, we are going to process the chunks and then put them into vector database. So there are 3 things that I'm going to put into this vector database. One is ID, it's going to be generated randomly. The vectors will be vector embedding of the text, and the payloads, which is the original data of the metadata as well as the text. Then we are going also to include that into the vector database. And the second step here, this is the codes to process and upload the data into a vector database. So let me run that. It's gonna run for a few seconds. Once we have that completed, and we can check like what we have here on the vector database here. So we have the ID, we have the file name and text, that's the original text, and we also have the vector embedded here. So that's the entire process for processing the data, and we are going to continue with the chatbot, allowing the chatbot to respond based on the provided data. Okay guys, now we have the data processed already. Let's integrate the data into the chatbot. So we need to import again the same libraries that I have used on the data processing earlier. And then let's go through step by step into the codes again. So you can see here the agent state, I don't make any changes at all. So let me run this library and then run the next one as well to check the state. And then again, we need to initiate the Qdrant configurations, the same as I did for data processing earlier. Now the big changes is here on the functionalities. So the add underscore user message, you know it already, and then also the generate AI response, you know it already. So there are two functions that I have added here. One is the get embedding, nothing new on this one. This is the helper functions to process the user input. So the text here will be referring to user input, and we are going to convert that into a vector embedded. The reasons why we are converting that into vector embedded is here on the second functions here. So essentially, once we have the user input, we need to convert that into vector embedding. And once we have the vector embedded, then we are going to do a semantic search or semantic similarity search versus the text that we have put together earlier in the vector database. So this function search essentially is going to compare the user input, which is already converted into vector embedded, versus the data that we have here in this vector database of Qdrant. So I have limited into 3 chunks only. Then this process is going to upload 3 texts or 3 chunks to be used in this chatbot. And then the data will be stored here in the extracted data. As you can see here, it's going to loop into that data. So if we put here 3, it's going to be like 3 chunks. And then we are going to pick up the file name as well as the text. Once we have the data, which is stored in the extracted data, then we are going to rewrite the query, and we are going to include the extracted data into that query as a context. So as you can see here, please answer the query based on the state message, which is from the user input, and then based on the provided data. And then I have explicitly declared here, please provide the response based on the provided data and your previous response if the new query is the same, nothing else. Then once we have that rewritten query, then we are going to put them into human message, and then we are going to append that into the message. So we have that user input as a rewritten query, and we are going to pass it on into the generate AI response functions here. So let me run that one, and then you can see here on the graph, so essentially I need to add one node, which is the second one, retrieve relevant text, and then of course on the edge I need to change as well the flow. So after add user message, then I need to retrieve the relevant text, and then the relevant text will do the job, will append the data, and then we'll rewrite the query and then pass it on to generate AI response. So let me run that one. So we have the graph ready, and then we just test and run the workflow. So let me ask about something randomly and see what we get here. Tell me about the weather today. Let's wait a few seconds. So we get the answer here. So you can see here, I don't have the real-time weather informations in the provider data. So we have an indications that the chatbot is referring to the provider data. And then the chatbot also telling us that the data contains only information about T5 models and other things here. So why don't I ask this chatbot about the T5 models? Okay, tell me about the T5 models then. Let's wait another few seconds and see what we get. Okay, so we have here, there you go, the second question that I have put together here is the, okay, tell me about the T5 models then. Then you can see here, based on the provider data, I can tell you about the T5 models, blah, 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 so on and so forth. Okay, let's ask about anything else. Tell me anything else you know based on the provided data. Okay, let's wait a few seconds to get the results. Okay, so it gives us some information about anything else that the chatbot knows from the provider data. So there is a bird. Okay, we have also GPT, GPT-2, so on and so forth. Okay, let me ask about the T5 model again. Tell me again about the T5 model. So I just want to see like how consistent the response is, because we have provided data and the chatbot also have the chat history as the context. So I would expect that the chatbot would give very similar answer to the previous answer with regards to the T5 model. So okay, if we look at here on the key points, there are 5 points here that is provided for the T5, and then the last line talks about the distributed training as well as the mixed precision features. So let's check again the first answers provided by the chatbot. So we also see like 5 points here, and then also the last line looks quite the same, if not exactly the same. So yeah, there are consistencies here on the chatbot based on the provided data from the data processed earlier. So I think it's a good indications that the chatbots are remembering the chat history and also referring to the provided data only. So the chatbot does not answer any random questions outside the provided data. So with that, thank you, and I hope to see you again on the other content sessions.